before I'm gonna start the service part, right, and the topics that we are gonna review it, a quick question to all of you guys. What do you think? What is the difference between the enterprise and service provider? What do you think? What's the difference between this guy? Yeah.
Well, the main difference as a service provider is you provide internet services. I mean, in simple words, obviously we
Yeah.
can say a company you provide as a service provider company, you provide internet services, and on top of that, you provide the other services. I mean, the main primary service will be the internet service.
The
But if you
main
compare
primary
with,
service, right? Internet
yeah,
only. It's a good answer, right? So the name itself is saying that service provider means what? I'm gonna provide the services. That's the meaning of service provider. And enterprise means what? We are gonna even in the enterprise network, we are gonna provide the services to the customer network. So let me quickly differentiate these two things, right? Because this is a very important part. Let's take example right now. I have I have a company ABC, right? And the company ABC, we have a multiple branch office, right? So you can assume that there's a 2 and 3 branch office in the different locations. So let's say example, this is the PCA, okay, and this is another PCs we have, and this is they are connected to the switch network, and this is how we are connected, and then the switch is going to connect with the router right now, the router number 1. Then switch also going to connect with the router number 2 right now, okay, and then switch also going to connect with the router 3 right now. Okay, and router 2 and router 3 is running with the HSRP protocol because they all belong to the what? They all belong to the same network right now. So they are running with the HSRP protocol in the LAN segment. Okay, and then finally, these guys are connected to the to the edge network, edge router. So this is my edge router, router number 4 over there. And this router number 4 is gonna connect with the service provider. So this is my service provider area. And in this service provider, this router is going to connect with the router number 5. Okay, then router number 5, we have a router 6 as well in my service provider network. Then we have a router 7. Then we have a router 8. Then we have a router 9. We have a router 10 over there. We have a router 11. And in the core, we have also a router 12 we have. And router 13 we have. Now, this is the one branch office in the some location. I can call it this guy in the one location. Assume that it's in the Mumbai right now. The same company ABC. The same company ABC have a different branch office in a different location. For example, I can call this guy. This is gonna connect with the router number 10. So router 10 has a connectivity with the router number 14 right now. Router 14 has a connectivity with the single switch, single home connection we have. And then we have some users over there, PC1, and few servers are present in this site. The small network or a small location, we can call it. So assume that this is the location we have in a very small city. I can call as a Jaipur is a very small, right? So Jaipur is a small city. So in a Jaipur, we have few few people are there. So that's a small is fine. At the same time, we have another branch office in the different location more. So I can call out this guy. R8 is going to connect with the router number 50 now. Okay. And then router 15 is going to connect with the switch. At the same time, this guy also have a dual connectivity right now. Not like this way. I can make it router 15. Let me make some space over here. Router 15. And then after that, we have a connectivity with the router number 16 and then router number 17. And then again, same this guy, we have a switch connectivity over there. And again, we have some users are connected with the switch, right? So we are totally discussing about the enterprise and service provider perspective at the same time. So our main focus is over what? Enterprise, service provider, and CCD part. Now, as right now in this Mumbai location, right? whatever the devices are we have right now, all they are running with the Cisco box. All they are running with the Cisco box. In this Jaipur location, they are also running with a Cisco box. But at this location right now, we have in different location right now, this guy, they are running with a different multi-vendor technology. So I can call this guy, they are running with the Juniper. I'm so sorry. This guy is running with a Juniper router, and this guy is running with a Cisco router. So in that case, you cannot go with the HSRP protocol, right? You have to go with the VRRP protocol. So we are running with the VRRP between the R16 and R17 so that we'll make a high availability over there. Now, understand this point is very, very important for you guys. Within the company, right? If you see in this location right in the Mumbai location, so this is the Mumbai, this is the Jaipur, and this is the Delhi, I can call it. Okay, so let me highlight this one. So this is the Delhi, this is the Jaipur, and this is the Mumbai location. If you see right now, in this case right now, the PC1 wants to communicate with the PC2, they can easily communicate through the local switching mechanism because they are the part in the same broadcast domain. If they are in the part of a different broadcast domain, the packet has to go with the router. That's called as the inter-VLAN routing. So within the domain right now, can you see that within this Mumbai location, if the router 1 and router 2 and router 3 and router 4 can exchange the route, they can go with the any IGP routing protocol. IGP stands for Interior Gateway Routing Protocol. So I'm not teaching you anything right now new. I'm not starting any topics right now. I'm just trying to differentiate the word enterprise and the service provider and how these guys are working internally, right? So within the company network, R1, R2, R3, R4, we are running with the any IGP protocol. I can run with the ISS protocol. I can go with the RIP protocol. Don't surprise with the RIP right now because still the people are running with the RIP protocol. I have seen that recently. I was troubleshooting one of the network right now, and I found the RIP protocol was running. So that's not a big deal. So EBGP either we have, or either we can have a OSPF protocol or a static route 2, right? In the small scenario. So the meaning of IGP means what? It's saying that, hey, it's an interior. Interior means what? Within the own organization, right? Within the own location, I can run any of this protocol to just provide the reachability between the router 1, router 2, router 3, and router 4. So I'm just assuming that, hey, you know one thing, I'm running with the over here as an ISS protocol. Let me do one thing. Let me go with over here, different color. So I'm running with the ISS protocol over there just to provide the reachability between the router 1, router 2, router 3, and router 4. Over here, what happened? Again, we have a different vendors over there. We cannot go with the EBGP protocol. I'm going with the OSPF now. Between what? Between the router 5, router 16, router 17. How about this person right now? Either you can go with the default route, right? Because this is a single home connectivity right now, or either we can go with the EBGP protocol. Can you see that what you understand over here right now? Within the company, right? Within the company, what happened? Even we are providing the services to whom? The PC1 to the PC2. Even this company network, within the company network, what happened? The PC is giving the services to the servers. Within this company right now, what happened? The PC can communicate to each other. So it's not like that within the company, we are not providing the services. We do provide the services. But that is locally to the own company organization network. That is locally to the own company network. That is locally to the own organization network. And to provide the reachability between all this guy, we are running with any of the routing protocol. So I'm running with the ISS over there. I'm running with the OSPF protocol over there, and I'm running with the EBGP protocol over there. That's the meaning of IGP Interior Gateway Routing Protocol. Interior means what? Within the same company. Same like you have a family, right? Family. So if you're not communicate within the family, you can use the IGP protocol. That's the meaning of interior. Same thing over here. What happened? Router 5, router 6, router 6 to router 7. Understand this concept right now, because most of the people get confused over there. Why should I go with the BGP protocol and why should I go with the OSPF protocol? So between this guy to this guy, understand this point, this guy to this guy, this link that I'm pointing over there. All this link, right? We are going to run with the any one of the IGP protocol. So you may have a question, can I go with the EBGP or can I go with the static route? Or can I go with the ISS protocol? Now understand in the form of the CCD perspective, the design perspective. You can provide the reachability, the link that I have highlighted over there, the green color. I can provide the reachability between all the subnet right now. You can see that we have a subnet between R5 to R6, the 56.0. We have a 67.0 network. We have a 78.0 network. Same way, we have a 138.0 network. We have a 123.0 network. We have a 125.0 network. We have a 115.0 network. Then send the 110.0 network and 109.0 network. And then we have 98.0 network. We have all the routes over there. To exchange all the route, we can go with any routing protocol. But the recommendation is what? The recommendation, you have to go with the ISS protocol or OSPF protocol. The reason is that to go with this two protocol, because this two protocol can support the traffic engineering. So if you're planning to implement the traffic engineering in your network, in your service provider network, or we can call it segment routing, the advanced version of the traffic engineering, you have to deploy this two protocol. This two protocol can work with this two technology. If you're going to run with the EBGP protocol or if you're going to run with the RIP protocol, this two protocol cannot support the traffic engineering and segment routing. There is a many advantage of this two protocol. We'll see that when we are going to discuss about this two protocol separately. But right now, as per the design perspective, we are planning to implement the TE in this network. So that's why we can go with any of the link state routing protocol. In the organization itself, right? I can go with any of the routing protocol, EBGP, OSPF, RIP protocol, any of the thing, because we are not running with the traffic engineering over there. But in the service provider network, we itself gonna run the traffic engineering over there. So I have to go with any of the link state routing protocol. Now you may have a question, which protocol, ISS or OSPF? That we'll see later on. So to provide the reachability between all the subnets, I have run one of the protocol, either OSPF or ISS. Now what? So if all this protocol was there, right? Try to understand this thing. If all the IGP protocol was there and it was sufficient right now, even if it is sufficient nowadays, then why they introduced the protocol known as a BGP? Then why they introduced the protocol BGP? Do you know one thing? Whatever the protocol that you are seeing right now on this dashboard right now, all this protocol was the 90s, 80s time. They like engineers made an enhancement in the protocols, and they relaunched the different RFCs, different features over there. But originally, these protocols came in the 90s, 80s time. At the same time, the another protocol was there that's called the EGP protocol. EGP has some issue with the hierarchy. You need to follow the hierarchy when you deploy the EGP protocol. Then EGP was replaced with the BGP protocol. So before the BGP, EGP was there. And that's why it's called as a exterior gateway routing protocol. So the question comes in the mind, why should I go with the BGP if you already have all IGP protocols? Try to understand what happened. If I'm going to use the OSPF protocol between the R4 to R5. Or maybe the ISS protocol. Take an example of the ISS protocol right now. Or between this guy, I'm going to run with the OSPF protocol. And between this guy, I'm going to run with the EBGP protocol. What happened if I'm going to run any of the IGP protocol between the companies to the service provider? If you're going to use the IGP protocol, in that case, what happened? You need to do the huge number of redistribution on the router number 5. You need to do the redistribution on the router number 5 and router number 8. You need to do the redistribution on the router number 14 and router number 10 because different routing protocols require the redistribution. And second disadvantage is what? You tell me one thing. Will this user is ever interested to send the traffic to this network or this network? No. If this user is not going to interested to send the traffic for this particular network. So if you're going to run the IGP protocol between this guy, what happened? All this information will be exchanged with the customer. All the service provider information will be exchanged with the customer. All the service provider information will be exchanged with the customer. That's a problem. IGP protocol is not so scalable protocol. That's why we came with the solution is called what? That's why we came with the solution is called a BGP protocol. So whenever the requirement comes in the picture, right, between the company's network.
Now, can you just explain the last drawback?
Okay. So take example, if I'm going to run the OSPF protocol over there, right? OSPF over there and maybe the REP protocol over there, or maybe the EBGP or maybe the ISS protocol over there. In that case, what happened? So ISS protocol, all the routes comes to the router number 4 as an ISS protocol. Then you need to do the redistribution, right? Once you do the redistribution, yes, this route comes to the R5, right? Again, on the R5, what happened? You need to do the extra redistribution to bring the OSPF route into the ISS protocol. Same thing, yes. R5 will receive all this information through the OSPF protocol. And what R5 will do? R5 again do the redistribution into the REP protocol. And again, you need to do the redistribution on R8 to exchange the route into the ISS protocol. Same behavior will happen over there, redistribution and redistribution. Another panga, another problem is what? Once you do the redistribution, same thing, you need to do the redistribution from this side as well as, right? This side as well, yes, as. So if you're going to do the redistribution from this side, what happened? All this information, right? Can you see that all this information is going to exchange with the customer network? Now you tell me one thing. Will this customer ever gonna send the traffic to this particular segment? No.
No.
Customer always gonna send the traffic to the customer, right? Not to, yes, the service provider, this transit network. So IGP has a limitation.
Bother about this.
Yeah, IGP has a limitation, man. Okay. And that's why we came with the protocol is known as a BGP. What BGP allow you, first of all? What BGP allow you, first of all? The BGP say that exterior means what? Between the company. So BGP itself have a 2 protocol. One is called as a EBGP and another is called as a IBGP. Guys, please pay attention over there because here your most of the confusion will be lost over there. Once you understand this form, then you will have a clear picture what protocol should I run and what protocol should I not run. Between the companies, right? What I can do over there? Between the company, I'm going to run the flavor is called as the EBGP. Between the company, I'm going to run the protocol called as the EBGP. Guys, it's a recommendation to run the protocol. It's not a mandatory. It's a recommendation. You can run the OSPF2 over there. You can run the OSPF2 over there. It's totally depend on the company and service provider agreement. If the customer wants, I need to exchange the route through the OSPF protocol. And if the service provider is agree, then you can go with the OSPF protocol. That's again, it's a recommendation to go with the BGP protocol. In that case, what happened? You can reduce the lots of complexity.
when it is not scalable.
You cannot say that not as scalable, but the problem will happen with the routes. You will lose the security.
That's true, but if this many routes will come, will not
Exactly,
control routes.
that's a meaning. So
Yeah.
you will lose the
Yeah.
security because this route comes to the customer network.
Yeah. And but the major thing is like whether the router, which is like if you talk about in this scenario, router 4, whether it is able to handle those many routes.
That's
That is also
that's another point, right?
so.
OSPF
That is what
protocol.
that's why I said scalability.
Exactly. Recently, if you, I'll tell you what happened. I was on the one customer call, and I found 1 million routes in the routing table. That's a BGP route. This amount of route is not able to handle by the any of the IGP protocol, because this IGP protocol is not designed to handle the different company routes. It is designed for the interior means what? Own company routes, not the different company routes. So that's why we have to go with the protocol BGP. What flavor I'm going to run over there? EBGP. What flavor I'm going to run over there? EBGP. Between the R8 and R5, what flavor I'm going to run over there? EBGP. Now understand the concept over there, what happened. Do you know in this case what happened? You only need to do the redistribution on this router number 4. How? R4 will receive this all information. For example, we have a running with the 1.0.0.0.2 and 2.0.0. These two routes are there in the company network. So this route comes to the router number 4 as the ISS routes. R4 is going to do the redistribution and exchange this route to the BGP protocol. R5 will receive this route as a BGP. Right? Same way. R5 need to do the redistribution, OSPF into the BGP, and R8 will receive all this route through the BGP protocol. Same way, R14 need to do the redistribution, and R14 will send the all information to the R10. So try to understand, now we are removing the load from the service provider network. We don't need to do the redistribution on the service provider network now. How to exchange the route within the service provider network? Now what I can do over there, we are going to form the IBGP relationship between R5 to R8 and R5 to R10 and R8 to R8 to R10 as well. Don't include the route reflector and those things right now. Forget those parts. It will make complicated right now. So normally what happened when I receive the route from R4 to R5 through the EBGP, what I can do that over there, I'm going to make a IBGP relationship between the R5 to R8. I'm going to make an IBGP relationship between R5 to R10. I'm going to make an IGP relationship between the R8 to R10. So through the IBGP, what happened, I can exchange this route to the R8. This beauty is not possible in the case of OSPF and EGRP. Do you have an ability to make an indirect neighborship without adding an extra feature in the OSPF or EGRP? No, you don't have. Because the TTL value of the OSPF protocol is what? The TTL value of the OSPF protocol is 1, the default TTL. And the TTL of the EGRP protocol is what? 2 and 1. 2 is for the older iOS version and 1 is for the newer iOS version. How about the TTL of the IBGP? You can manipulate that TTL. So you do have an ability to form the indirect neighborship between the R5 to R8. It doesn't matter how many hops in between. That is not possible in the case of OSPF and ISS protocol. So in that case, what happened? R6 is not going to maintain the customer route. R7 is not going to maintain the customer route. R11 is not going to maintain the customer route. R9 is not going to maintain the customer route. R12 is not going to maintain the customer route. And R13 is not going to maintain the customer route. Think about the CCD perspective, guys. I can save the huge cost. How? I don't need to put the higher amount of router over there. I'm only going to put the higher amount of router like a ASR on this person. I'm going to put the
700.
ASR on this guy. I'm going to put the
10.
ASR on this guy. All the remaining router is not going to maintain the customer route, and that allow you to do the BGP free core topology. So in the core, we are not going to run the BGP. See the beauty that is not possible with the IGP protocol. Again, if you think about the IGP again now, how many ways you can manipulate the path in the IGP? If you think about the OSP protocol, how many ways you have to manipulate the path? Cost, AD, that's it. Or you have a, if you have a like a use manipulation things in the OSPF, you can do the summary route as well. So with the help of summarization, with the help of costing, and with the help of what? AD value, you can manipulate the path. But again, these are the limited part. But in the BGP protocol, you have a huge number of attributes. And based on the attributes, you can manipulate the path almost 15 plus ways. IGP is not so scalable. Now again, question comes in the mind. So if the IGP is not so scalable, so why we are running with the IGP protocol inside the service provider network? This is the most very, very important interview questions, right? When you go for the higher level of the package, when you go for the designing level of the network architect, right? Jobs, they will ask you, hey, why I'm running with the IGP protocol inside the service provider network if you already have a IBGP over there? Try to understand one thing over there. IGP helps the BGP protocol to provide the reachability of next hop. Remember, if your next hop is not reachable, in BGP, right? If your next hop is not reachable, then BGP never consider that route is a best route, right? If your next hop is not reachable, and if the route is not best, then BGP or not BGP, then router cannot install those route into routing table. That's a problem. So here, what IGP protocol is doing over there? To just make a reachability of this subnet, right? So that IBGP can exchange the route and next hop is reachable. So take example, I have a loop back over there. That's a 5.5.5.5, takes another color right now. So I have a loop back over there, is a 5.5.5.5.5, and I have a loop back over there, 8.8.8.8. So this loop back is reachable by the any of the IGP protocol. This loop back is reachable by the any of the IGP protocol. So if it is not going to reachable, then what happened? Your BGP route cannot become a best route. So you may have a question, can I provide the reachability with the help of BGP protocol? Instead of running with the ISS and OSPF, can I run the internally BGP over there to all advertise all this link into the BGP protocol? Technically not, right? Technically not, I can say that, because you can run it, but technically it's not recommendation to run it. If you're going to run the BGP protocol, take example, if I'm going to advertise this route and this route into the BGP protocol, then what happened? R8 is going to send all this information to the customer network. which information? All this service provider information. Same thing, R5 is going to send all this information into this guy. And service provider, this guy also going to send all the service provider core network information to the customer. And you will lose the security. That's why it is not recommendation to run the BGP, right? That's why it's not recommended to advertise this route into the BGP. It is recommendation to run the IGP protocol, right, inside the service provider network, so that this route cannot go to the customer side. So BGP protocol, IGP protocol, both are required in the service provider core. Can you see that? We are running with the EBGP over there between the customer and service provider, between the customer and service provider, EBGP, between customer and service provider, EBGP. Between P router, right, P2P, we are running with the IBGP protocol to just exchange the route so that R6, R7, R12, R13, R11, R9 cannot maintain the customer route. I can save the resources on this router. That's allow you to achieve the BGP free code topology. And to just maintain the next hop reachability, I can go with the any of the routing protocol, either OSPF or ISS protocol. What people are thinking about about the BGP or IGP protocol? People always confused about it. If you have a IGP protocol, then why we are running with the BGP protocol? And if you have a BGP protocol, then why we are running with the IGP protocol? Dude, both are a mandate part. IGP is just helping the BGP protocol to provide the next opportunity. If you don't run the IGP, your BGP will not work. It's like a phone and SIM card, right? Your phone is a BGP, right? Or your SIM card is what? Is your IGP protocol. Both is required. If your SIM card is not there, right, you cannot make a call. Right? The next opportunity, you cannot make a call, right? Same thing. IGP like a SIM card. IGP must be there to make a reachability of the BGP next hop. This is all about the fundamental of the service provider. What should run, what should not run. Guys, questions? Ahad, Adan, Sarvjit, and Kumar Swami.
No, not as of now.
No questions, sir. It's
No,
clear.
it sounds clear. Thank you.
Yep. Now, okay, that's the main difference between the service provider and the enterprise network, what we are doing over there. Now, one more thing that I like to point over there. Service provider means what? We are going to provide the services. What services we are going to provide it? So normally the service provider give you the services like internet services, right? Connectivity services between the customer side. VPN services. The VPN will include the layer 2 VPN and layer 3 VPN, and even data center services. Like you can host your own server in the service provider network. That's called as the data center services. Many services are there that is done by the service provider network. Now let's come back in the history now. So this is all about the basic difference. If you come back to the history in the 90s, 80s time, or 90s, let's go back to the 1959, right? When the ARPANET comes in the picture. And one thing, the first communication was happened, right, in the 1959 between the 4 universities. I'm not able to recall the name of the university. If you have followed my Instagram pages, right, I have uploaded all this information over there. The first communication was happened between the universities over there. And gradually what happened, the demand comes in the picture. In 1972, the first email exchange what happened. 1984, what do you think? Who came in the picture? Cisco. Neither around 1972 or 1975, I'm not able to recall the exact date, but the first router was introduced by the which company? Xerox. It was not by the Cisco, it was a Xerox. So I'm just saying that this point in 90s, 80s time, if you think about it, for the user perspective, right? Whatever the things were requirement, whatever the user can do it in the 90s, 80s time, they can either do the email. On that time, printer was also there. So they can print the something, right? Through the networking and database. They can exchange, like access the data. These are the major services, right? These are the major services on that time the people were using. What do you think in 90s, 80s time to just maintain these services? What should be the requirement of the operating system? Of course, right? Anything you are doing right now, all is done by the operating system. From your laptop to a mobile or router, every devices has an operating system. In the 90s, 80s time, the first iOS came, right? It's called as the Internet Operating System. If I talk about the Cisco perspective, iOS. And you know, the size of this guys were 256 KB only. And then it was enough. It was enough to do all this task. Gradually, what happens, like, you know, Cisco made some lots of improvement in the iOS. They made some the 1 MB, 10 MBs. And in the 90s time, right, what happened? We had almost 15 million user on the earth who were using the internet services, right? Networking services. The 15 million, it's equal to the right now, almost the 1% of the Indian population. But still, iOS was able to handle, can you see that? It was able to handle all the services. Even the users was gradually increasing. Then, if you come back to the 1992 or 1993, I can call it. In 1993, they came, like, you know, IP addresses was like exhausted. They came with the concept is called as a classless. And whatever the routing protocols we have, EIGRP, OSPFv2, BGP version 4, all the classless routing protocols came in the picture in the 1993. In 1995 or 1996, I think so, they came with the concept is called the RFC 1918, called the private IP addresses range. See how they gradually, on that time, the internet was gradually increasing, right? 1996. Then in 2001, the RSTP protocol comes in the picture to make a faster convergence on the layer 2 network. In 2000 something near around, if you remember that, if you guys have used, right, Orkut, social media comes in the picture, right? Amazon. So near around 2000s, right, what happened? Many users were on the internet. Like in 90s, 80s time, we had an email printing database. Now in the 2000s, what happened? We have a online banking, online shopping, or could feel like a social media was there. Internet was heavily gradually increased. Email was there, printer was there, database was there. Many things came in the 2000s, near on 2000s. To maintain all these services, right? Because the user was huge in the 2000s time. Can you see that in 1959 only the 4 PC was there? 1959, and then in 90s and 15 million users, and in 2000 the services came in the picture. To maintain these services, right, iOS was not sufficient. Then they came with the picture is called as a iOS XE. A higher upgradation. Again, I'm only talking with the Cisco perspective, guys. Okay, so different vendor has a different things. In 2004, they came with the concept is called iOS XE to just support these services. But again, iOS XE has some own limitation, right? If I go with the more depth, they can only provide the memory protection. To only routing protocol. So iOS XE said that, hey, you know one thing, for each routing protocol, I can dedicate the separate memory, which is not possible in the iOS, right? That's a major difference. And of course, iOS XE is more powerful than the iOS. But in 4 months, only 4 to 5 months, what happened? They came with the concept is called as a iOS XR. And it was very, very powerful. The first iOS XR was implemented in the CRS router. CRS1. People now, still nowadays, they are using this router, right? Who are very older companies right now. But it is nowadays they are replacing this router with the NCS or a split file router. The problem with this router is a huge, man. It's a huge problem with this router right now. This guy said, hey, you know one thing, iOS XE has an issue, only provide the memory protection with the routing protocols. Now, forget the routing protocol. I'll provide the memory protection for each and every process. iOS XR allow you to restart any process without impacting to the another process. For example, you can restart the OSPF process 1 without impacting the OSPF number 2. So this router, can you imagine that from the day of the 2004, still we are using the same iOS even now in the 2023. Of course, right, they are doing some upgradation in the versions, or they are adding the SMUs, like, software maintenance upgrade, to adding the more features and more features. But can you imagine from the 2004 to now, it's almost 20 years, we are still using the same iOS. The reason is that it's a very, very powerful router. Sorry, iOS. And even the lots of things have changed, man, from the configuration perspective, even iOS. And if you see the iOS and iOS XE has a, let me write on this thing just for your information, router iOS and iOS XE. If I talk about this two router right now, for example, if you run the routing protocol router EBGP, you just need to put the router EBGP command, right? And after that, if you just want to change the hello timer or hold on time, you need to go under the particular interface and say that, for example, gig 0 is 0. You need to go and change the IP EBGP hello timer or something like that, and change the hello timer. So if you see, there is no hierarchy. If you see, there is no hierarchy in the iOS and iOS XE. iOS XR said that, hey, you know one thing, I'm gonna maintain the 100% hierarchy. So whatever the commands you're gonna do, whatever the changing the timers or summarization or whatever you're gonna do, you are gonna do itself under the single box. So if you're gonna advertise the network, you just need to enable the interface in the network. If you're gonna change the hello time, you need to change the hello time. If you're gonna do the summation, you can do the summation over there. So you don't need to change the modes. Can you see that? I was changing the mode from exit, then comes into this mode. Over here, we do not change the mode over there. So it is giving you the 100% hierarchy, which is not possible, right? In iOS and ISXC.
So where exactly we are getting this?
Sorry?
This one, the selected one. This
This one,
hierarchy.
right? This hierarchy in the XR.
XR we are getting, but in iOS or iOS XP
We are not getting it. We are not getting the 100% hierarchy. We are not getting.
Okay. At some point of time, we have to exit and then we have to do the changes.
Exactly. See, if you do not summarize, you need to go in the interface. If you want to advertise the network, you need to go in the router EHRP mode. Okay, if you want to change the password, you need to come in the interface mode. You have to go and change the mode. So it's something like that. You know, you need to changing the mode for this is the router EHRP mode. This is the interface mode. So the person has to go first in this mode, then this mode, this mode, this mode, this mode, this mode. But in the case of iOS XR, single mode. All those things you can do in the single box.
Understood.
So that's a major, like, you know, just quickly recap. If you see from the 9059 to the 72 email was there, printer for this thing, iOS was good, man. But when the things are gradually increased, 15 million users was there in the 90s time, right? Things were changed in the 2000s time. What happened? Online shopping came in the picture, right? Social media, then internet has a huge requirement. iOS could not able to handle all those things. They came with the concept of the iOS XC. iOS XC allow you to do the memory protection for only for the routing protocols. But then again, in the later 4 to 5 months, they changed it. Okay, let's go with iOS XR now. And right now in the market, if you see, iOS XR is working on the ASR 9000. Yeah, the new in the new right now in the market right now we have ASR 8000. That's called as a split fire router. Okay, then we have an NCS box. They are always running the XR and the CRS2. So people are not using the right now these two CRS router. Okay, even the people are replacing the ASR 9000 to the 8000. So in the market, mostly the new trend is right now it's a ASR 8000 and NCS. But still the people are using the ASR 9000 as well as, because right now, so there's no big difference over there, right? But yeah, hardware level, there's a huge difference in the ASR 9000 and 8000. What you will get in the CCI exam, right? If you're planning for the CCI or CCNP in exam, CCNP SP core or the CCI lab exam, you will get the all these three: iOS XC, and iOS XR as well as. What we are gonna learn it. We are gonna complete all this part. Service provider. So we are going to cover this exam, this paper, or this paper too. So we are going to cover the SP code. That's a CCNP, you can call it. And we are going to cover the CCI too. So I'll just open the one of the paper right now. Okay. So CCI Service Provider, because if you do the CCI, so it will all automatically cover. So I'll send you the link as well. So if you just want to follow the links, the topics, whatever the topics are there. I don't know, man. Okay. So if you see the 25% the core routing, that's gonna deal with the ISS OSPFv2 and version 3. That's for the IPv6, right? how you can optimize your protocol, tuning the timers, and how we can deal with the segment routing in the ISS protocol, and this one too, like what we call OSPF, right? Then we have to go with the BGP protocol, how we can do the BGP LU. So BGP LU is a different things in the iOS, and ISXR is a different. So in the iOS, what happened? This is just a single command. For the BGP LU, on ISXR, it's a totally address family. Like link state means what, like how we can exchange the link state routing information between the two BGPs, right? And then after that, we can go with the multicasting, right? In the multicasting, we are gonna go with all the labs, okay? And then after that, we can go with the RS traffic engineering too, right? And then we can move to the MPLS part. So in MPLS, right, what happens first, we'll do the MPLS Unicast, then MPLS VPN, then option A, option B, option C, then CSC model we have. Then what happened, how you can leak the route in the MPLS, how we can do the internet access through the MPLS, right? All these things we are going to do. Then after that, we can do the, what we call segment routing in the MPLS. What is the requirement of segment routing nowadays? People are removing the, traffic. Even I have seen people are using the segment routing within the own enterprise network. I'm not talking about the service provider. They're using the own enterprise network. That's a good thing. Like segment routing is a huge, I can call it enhancement they did it in the traffic engineering part. So people are removing the traffic engineering and they are putting the segment routing. So I just quickly say that, let me pause the recording for this right now. Then after that, we cover the TE part. Then we'll go for the how you can deploy the unified MPLS, right? Also, previously it was not there, right? Before the BGP-LU, the unified MPLS was not there. So BGP-LU played a big important role in the unified MPLS. Then after that, we have a layer 2 VPN, man. So layer 2 VPN is a amazing things, because most of the time a customer take the layer 2 VPN instead of the layer 3 VPN. We have an advantage and disadvantage. Of course, in the layer 2 VPN, what happened? The customer is not gonna share the own routes to the service provider. Security improved, customer perspective, right? But in the layer 3 VPN, what happened? Customer is sharing the own routes to the service provider. The customer is losing the security. So there's a huge difference. I just gave you the one of them. And then after that, we are also going to see the EVPN. So mostly people are confused about the EVPN. Let me quickly recap this one. So what people are thinking about the EVPN VXLAN. This is the confusion of the people. I'll tell you what happened in a data center. So now let's take an example, VXLAN, right? So VXLAN is, you can implement the VXLAN in 3 ways, right? Ingress replication we have, right? Then we have a head and flood and learn. So we have 3 ways. Ingress replication. Then we have flood and learn. And then we have EVPN. These two the people are not using because these are the legacy, not legacy you can call it. These are the huge disadvantage. Okay. In EVPN we have. So EVPN is further, it is for the service provider and data center too. So in a data center, what happened? We have a VXLAN to support the EVPN. Okay. In service provider, we have a MPLS to support the EVPN. So this is the problem with the most of the people right now in the market. So they think that VXLAN means data center. The first of all, when the VXLAN comes in the picture, people think about the data center. No, it's not like that. You can, first of all, the VXLAN is what? You have 3 different ways to implement the VXLAN. One of the ways is called as the EVPN. Right? EVPN, if you're going to use it in the service provider network, the data plane is going to work like an MPLS. If you're going to use the EVPN in the data center network, then it comes in the VXLAN, because in a data center network, you'll not see the MPLS over there. Then after that, we can go with the, what we call layer 3 VPN, man. The layer 3 VPN, as I told you, the extranet and internet accesses, right? How you can integrate the segment routing in the MPLS part. Then we have a NAT concept. And then the most important part of the multicast is browser VPN and next generation MVPN. Also, we are going to discuss about the GRE over the multicast and the DMDP over the multicast too, right? So this is not a part of the syllabus, but I'm going to discuss this thing as per the CCD perspective. So you will have a clear picture. What should I implement and what should I not implement? And then after that, we have a quality of service, right? The pipe mode. It's not there. Yeah, it's there now. So most of the things are the part of the routing setting, right? These are the most important part of the service provider. But again, we are going to discuss each and everything over there. And then last, we have a access connectivity, right? How you can do the between the P2C routing, because a very easy one, not a hard. And then high availability means what? Like how you can provide the high availability in your router. Like we have a 2 RSPs or a RP we have. At the same time, through the protocol, how we can provide the high availability. Like a BGP pick in the case of BGP, right? You can achieve the faster convergence with the help of BGP pick. But again, BGP pick has some limitation in the XR. I'll show you that one, don't worry. And then we have a security, right? How you can implement the C. Whenever the security comes in the picture, the people are thinking about security means what? Enterprise network. Only we can provide the security to the enterprise network. No, it's not like that. You have to do the security in the service provider network too. Okay, I'll quickly give you the one glance. So take example, this is the C, right? This is the P. This is the P router. Another P router. And this is the C router. So this is the interface 0/0, this interface 0/1, this interface 0/0, this interface 0/1. Quick question to you guys. Okay, on which interface I'm going to run the MPLS? Tell me. On which interface I'm going to run the MPLS? On which interface I'm going to run the MPLS?
Provider edge.
Router?
Provider edge 0/1.
No, no.
Receiving interface.
Yeah. Between customer edge and provider edge.
No. Are you running the customer and provider the MPLS over there?
No.
No. We are going to run the over there. We are going to run over there. We are going to run over there. We are going to run over there. This is the recommendation to run the MPLS over there. Now I'll tell you one thing. Why? Why should I run the MPLS on this provider network? Why should I not run the MPLS on this guy? Why the service provider is not allowing you to run it? You know why? This is the security comes in the picture. Take example, if I'm going to allow the customer to run the MPLS on this guy LDP protocol and LDP protocol, don't you think it will make an attack in the core network, LDP attack, if they have LDP information? It can do the LDP attack. It can do the LDP DOS attack, DDoS attack. That's why it's not recommendation to run the LDP on the customer facing interface. So there is a mini, what do I call it? There is a mini security that we are going to learn it through the, this training. These are the basic part, man. Whatever the control plane security is given, but we are going to discuss in the use in the security part. And then last, we have automation. So mostly automation, this is all we are going to do on the iOS XR part, XC and iOS. So all the training, all the practicals that we are going to achieve it, all the practicals that we are going to do it, all we are going to do on the iOS XR, sorry, XC and iOS XR. So that you can easily, correlate the things, which one is good, which one is bad, and how the configuration are different from each other. So it's not like that in this complete service provider. I have seen that multiple peoples, they teach the service provider, they are only going to discuss on the iOS part. Most of the commands they do on the iOS, and either they can do the XR. It's not like that we are going to discuss on the complete. So if, for example, if we have a topology, on a topology, we are going to discuss on the iOS, iOS and iOS XR as well. Okay. And the second thing is that we are doing a complete lab on the EBNG, Okay, so I have already installed the XRV image. So we are going to do the complete lab on the EVNG XRV. I have a XC as well as implemented over already. And I do already have a as normal device as well. So complete lab we are going to do on the EVNG. I will share you all the documents, okay, all the service provider books you need. If you want to read the books, it's fine. If you don't want to read the books, it's fine. Just follow the videos that I'm going to teach you, or just do the lab that I want to show you in the, during the classes. That's enough one. But even if you are interested to, what we call, to read the books, I have a plenty of books of the service provider. So almost I can refer you the 10 to 15 books to read it for the service provider if you want. But again, it's totally up to your call, man. If you
PDF,
don't,
it would be PDF, right, or physical one?
it's a of course PDF, not the physical.
Okay.
Physical is very costly, man. Like I took the 3 books of the service provider right now. It's cost me around 20,000 right now.
Mm-hmm.
Okay. So even
Will you help us to install on our laptops?
definitely. So you must have, right? You guys have
I
done
was
the
having
16
it.
class.
I was having it, but due to some reasons, I have to remove it.
Okay, no issue. We'll implement in a laptop too, right? You just reach me, either the Puneet, you can reach out to Puneet, or either you can reach out to me. I'll refer to the
No problem.
one of my student, so they can install in your laptop.
Okay, fine.
Now, what are the minimum system requirements to install the EVNG?
I'll tell you, to be frankly, right? If you have a 16 gig, it's fine. Okay, you can do it. Okay, 8 gig, I'm not gonna recommend you to install the XR image. Okay, it's gonna hit the CPU. 16 gig is good, and if you have a 32 gig, man, it's amazing then.
Yeah, even 16 GB will struggle because I've tried that.
No,
Um,
I like my laptop is a 16 gig right now, so I'm able to install it. But most of the, because I bought the server, so that's a 385 gig of RAM. So I'm a
Right.
custom server. So right now, I'll show you. So this is the RDP I took it, and
385. So
so
that means
this is my server right now. So normally I'm doing the lab. So I'm having the 3 to 4 batches of the CCIE service provider right now. I'm taking it. So CCIE SP. So this is the host of lab. Or this one, I think so. So normally if you see, I'm doing this is the one of the lab yesterday. I took the one system for the service provider, right? So this is the thing, like a basic lab of the OSPF, how you can implement the areas over there, multi-area concept. So I have all the XR over there right now. So for me, as a 385 GB RAM, so I'm doing the practice on my server.
it's huge.
This all the thing. But again, if you need a server access, right, you can connect to the Puneet, right? Puneet will help you to get the server access to, right, if you want. So they will charge you the minimal only, very minimal charge they are charging, and they can approve all this server access too.
Okay.
Okay, so I'm telling you, to be frankly, if you have a 16 gig, it's fine. 32 gig, it's awesome. If you don't have, just reach to the point, say whatever the lab is, because right now the 7 to 8 people are accessing the rack, okay, in the different locations, right? So this is the public IP I have, okay. So we took the public IP, and based on you just need to do the RDP, and once you do the RDP, you will reach to the EVNG directly, and it is always available. 24/7 is available. Sometimes it's create the issue, the light issue is there, like maybe the heavy rain is coming, so sometimes maybe off, but most of the time it's on 24/7. So you can do the lab on this one in server as well. So this is my syllabus, guys. I'm forget to tell you, this is the Cisco syllabus. What you want to learn from apart from this thing?
I think it's huge.
Is it
Almost
going to
covering
cover?
everything.
Sorry, is
Yeah.
it going to cover both CCNP exams?
Right. So I have
Once
already
we will
mentioned.
finish it. Yeah.
Yeah, so I've already mentioned that. If you see, so we are also going to cover This one as well, SP core.
The SP core. Yeah.
So if you see this exam reviews, so we are going to combine the same thing, right? So for example, we are going to do the OSPF lab. So same OSPF lab we are going to do with the CCNP and then CCI simultaneously.
Okay, got it.
And second exam can be, I think there are 2 exams, isn't it? So the second exam will be a different one.
That's already it's covered in the same one. So there's nothing major difference in that one.
Right. Okay.
I think it's only the one exam of the CCNP, not the 2 exam, man. There's only one exam. That's the SP core.
Encore.
Yeah, SP core,
SP
not
core.
the Encore. Encore is for the
Yeah,
enterprise.
Encore was for enterprise.
Encore is for the enterprise. Service provider, there is only one exam. And then after that, you can go with the lab. Encore has a, like, enterprise, if you do, in enterprise, we have one Encore paper. And apart from this thing, we have a 6 paper. That's called the concentration. Even the data center has a D code, right? If you go to the DC has a D code exam. And apart from the D code, they have a 4 to 5 exam, I think, so there. But the service provider, there is only one SP core exam, and you can go with the CCI lab if you want.
No, I was sorry.
core.
Yeah, I was under the impression there are 2. You need to go for core plus the optional one. But
No,
I think I
that's
was
a
wrong.
part of the enterprise.
Yeah. That's why I was mixing with that one. Yeah, that's
That's
right.
fine.
Thank you.
So if we have cleared this SP core 35501, maybe we can directly attempt for the lab.
Yeah, definitely. You can directly go with the CCI lab exam.
How much time you are
Let me.
taking?
I'll just pause the recording. I think so. It's fine, right? So we can pause the recording. Otherwise, recording.
Yeah, absolutely fine. I think.
Yeah.